Welcome, Algebra 2 folks. In this video, we are going to cover the Algebra 2a review for topic 1, which is on inequalities. This video, we're going to do the even problems on 13 through 30. So that's solving inequalities. So let's go. To make this video, I spaced this out maybe a little bit more than what is on the paper copy. So that's why it might look a little bit different, but it's the same problems. But all right, 17 through 30, you can read the instructions. We're supposed to solve the inequality, and we do have the instructions about showing a check step. And at least for a few of them, we'll run through that, but otherwise I'll try to go quickly. So we're going to do the even problems here. So just starting with number 18, I'm trying to solve for a. So all I have to do is subtract 12. That'll cancel. And then do that on the other side. Let's see here. I would get a alone on the left. I'd get negative 10 if I calculate 2 minus 12. And we subtracted, so we do not flip the inequality. So I'm going to keep that less than or equal to. This is my answer, but let's do the check step. I'll do here. So remember, check, first of all, basically is negative 10 the right number? Is negative 10 the correct number? Basically what I call the reference number. And the two sides should be equal. So if we do a 2 on the left, go back to the original, but we're going to switch that to an equals. And then we've got our value, quote-unquote value for a of negative 10. And then we're supposed to add to that 12. So let's see, is that true? Are they equal? And we can see pretty quickly that yes, 2, grab your calculator if you need it, negative 10 plus 12 does give you a 2. So they are equal. So this is the correct number. Negative 10 is the correct number. Yes, because of that. All right. Second thing is we did not flip the inequality. Maybe we should have flipped the inequality. So now we're going to check the inequality, whether or not we should have flipped it. I'm going to abbreviate NEQ. So I need to find something that would work for my answer and check if it works for the original. So negative 10 is less than or equal to a. Negatives are tricky, remember, so I like to use 0 a lot. 0 could go here. We could say negative 10 is less than or equal to 0. So maybe a equals 0. Because we could put that there on our answer. Now, a equals 0 agrees with my answer. Does it agree if we put it in the original? So now I'm using the inequality. Whether or not I flipped it, I'm using the inequality. And let's grab that 0 for a. And then we're adding 12 to that. And we're asking, is this true? So yeah, on the left side, just 2, less than or equal to. The right side, 0 plus 12 is 12. So yeah, that's true. So it seems like negative 10 is my correct number, and then not flip the inequality worked. So there you go. There's my final answer, and I did the check step. I'll do that maybe on a couple more problems showing the check step, but otherwise I'll just remind you what the check step is. So I was just going to do the evens. So next we go to number 20. So again, trying to solve for m here, trying to solve for the variable. So this is multiplication. I just have to divide. 5 divided by 5 is positive 1. Positive 1m is just m. And then divide by 5 on the other side. That's negative 4. And let's see, do I flip the inequality? I don't think so, because I divided by a positive. Even though there was a negative involved, I divided both sides by a positive. So let's check, is negative 4, is that the correct number? Is negative 4 correct? Should it have been something else? Well, it would make the two sides equal. That's the trick. That's what a lot of students miss. So if we put a 5, and then if we use that negative 4 as the value, again, I know m is supposed to be greater than negative 4 according to my answer, but if we use a negative 4, does that equal negative 20? You bet it does. This is negative 20. Negative 20 is equal to negative 20. So is negative 4 correct? Yes, it is. It's the correct number. I like it. Instead of like subtracting 5, and I would have gotten a different answer, or dividing by a negative 5 or something. Negative 4 seems to be the correct answer. And so next we check the inequality. is it correct to say that we should be greater than -4? So what could go in place of m here? What's greater than -4? Well, like on the last problem, I like to do 0. 0 is greater than -4. If 0 works, 0 is usually pretty easy to check. So that could be a value for m based on my answer. Does it work in the original? So if we do 5 times 0, will that be greater than -20? 5 times 0 is greater than -20. And again, this is easy. You know, I often talk about doing mental math. If you can, multiplying with 0 is usually pretty easy. So is 0 greater than -20? Yes, it is. That is true. So I like the inequality. There's my final answer. Okay, and we can move on to the next one. For number 22 here, I guess we can stick with the same color here. A little more difficult. This is what you might call a two-step equation. Some students want to divide by 7 first. You could. I'm not going to do this. I'm going to erase this. But if you divide by 7, everything has to get divided by 7. And if you look at this now, I go, oh, -6 divided by 7, that's not nice. 8 divided by 7, that's not nice. So it's not wrong to divide by 7. It's just everything has to get divided by 7. So that's why I say, you know what, let's maybe do something else first. Maybe let's deal with the 8. If I subtract that 8, that'll go away. Over here we got 7m. Over here, -6 minus 8 would be -14. We subtracted, so do not flip your inequality. Only if you multiply or divide both sides by a negative. So we still got a less than or equal to. Now I can divide by 7 to cancel that. And there's only one other thing to divide by 7. And in this case, it just so happens to work out nicely. -14 divided by 7 is -2. 7m divided by 7 is 1m, or just m. And then I divided both sides by a positive. Again, I know there's a negative on the left, but I divided by a positive, so no flip. But still, I would check that. So less than or equal to. Just for time, I'm just going to go more quickly here. So remember, if m equals 2, if you use that value of m equals 2, then you should be able to get -6 is equal to 7 times 2 plus 8. So you can verify that for yourself. And then if the inequality is correct, pick a number that you could put here. -2, oh boy, 0 again. Maybe I'll pick something other than 0 so we don't get locked into 0. 0 doesn't always work, but so maybe in this case m is -1. Maybe m is -1 because -2 is less than or equal to -1. So if you put a -1 for m in the original inequality, whoops, let's put question marks there. If you put a -1 for m here and you keep the inequality this time, would this inequality be true? And we should find that it is. Okay, but that's what you can do to check. All right, so I'm going to skip the check steps just for the time on the video. But let's keep going. We got 3 or 4 more. Number 24 here. Again, some students have been wanting to multiply by 4 for everything as a first step, and that's not wrong. But remember, I'm going to erase this because I'm going to do it differently. If you want to multiply by 4, everything has to get multiplied by 4, including the 10. A lot of students forget the 10. So if you want to multiply by 4, that's fine. Everything gets multiplied by 4. What I like to do instead is I like to deal with the addition or subtraction first. So that'd be the 10 here. If I subtract 10, that goes away. Careful that we're left with -r/4. And 8 on the other side. We subtracted, so no flip. Keep the greater than or equal to. This time, I'm going to multiply by 4, but I'm also going to deal with that negative at the same time. So I'm going to multiply by a -4. So I'm going to cancel the negative, and I'm going to cancel the 4 in one step. You could do it in separate steps if you want to, but if you want to work smarter instead of harder, multiplying by -4 would ultimately be your last step to solve for r, if you're doing it the way I do it. Over there, we get -32. We get 1r, positive 1r. I multiplied by a negative, so here I do flip. So that should become a less than or equal to, all right? and then again, the all-important check step. So if you use r equals negative 32, it should be true that the left side is equal to the right side. And be careful here, 10, we're subtracting. We've got the subtraction with the negative. A lot of students forget that, or they merge that. It's not 10 minus 32 over 4, it's 10 minus negative 32 over 4 is what we're checking there. And we can ask ourselves if that is true, and unless I'm making a mistake, you should find that it's true. And then when we're convinced that that is the correct number, that negative 32 is the correct number, then we can check our inequality, especially since I flipped. So is the inequality correct? So maybe in this case, this is another one where 0 agrees with my answer, but maybe I'll choose, let's see, we're dividing by 4. I'll choose negative 28. So if negative 32 is less than or equal to negative 28, so maybe r equals negative 28. That's one possible value. And if I put that in place of r, is the inequality true? So 10 minus, again, minus negative 28 over 4. Is that true? And what you should find is that does give you a true answer. All right, how many more do we have? 3 more, it looks like. Number 26. Let's see here. This is one, okay, this is a little tricky. Notice that we have multiple variables, but if you do this step and separate the left side from the right side, and if I look at the right side, if I temporarily cover up the left side, the right side is just a 9, so nothing to simplify. But if we look at the left side, if we temporarily cover up the right side, I can simplify on the left. So however you want to think of this, I owe 5 napkins, I owe $7, and I have 6 napkins. We can combine the napkins. They're on the same side. When we get to number 28, that'll be a little bit different, but negative 5n plus 6n, that's 1n, or if you want, just n. We still have the minus 7. We're only simplifying, so we don't flip. And then now we need that right side. Now I got to uncover that right side, so it was a 9. And if you get here, now it looks a lot like the first problem that we did. All you got to do, add 7, and you cancel the minus 7, add 7 on the other side. You got n is less than or equal to 16. Again, I'm going to go real quick with the check steps. So if you use n equals 16, the left side should be equal to the right side. And feel free, for those of you that feel comfortable with the calculator, you can punch all of that into the calculator and check to make sure it's true. If you're checking your inequality, check the inequality. So what would agree with my answer there? Oh my goodness, 0 works again. Okay, maybe I need to change some of these problems because 0 doesn't always work, generally speaking, but every problem we've done so far, 0 would be a solution. So maybe here, let's see, maybe n is 10. So maybe n is 10 because 10 is less than or equal to 16. So if I put a 10 where n is, do I get a true inequality? I'll say one more thing as I'm writing this out. Notice that I'm not going from my simplified version of the left side. I'm doing the original left side where I have to put that number in place of n in 2 places, just in case I made a mistake. Maybe it's not n minus 7. But yeah, so you can check to see if that inequality is true. You should find that it works out to be true. All right, we got 2 more. All right, this looks like a fun one, number 28. Again, just like we did on the previous problem, if you separate your left side from your right side, whoops, last one, sorry, forgot to box in my answer. Number 28, left side and right side. The left side over here does not simplify. 8d minus 76 by itself, it's 8 donuts and we owe $76. But the right side, we can distribute the 6, what I call the wink and smile. So the left side is just going to hang out and wait. Simplifying, I'm not doing anything on both sides. I'm just simplifying, so no flip. But 6 times 4 would be 24. 6 times, I'd count that as a negative 2d. It's negative 12d. And then the minus 5d is not in the parentheses, so that just hangs out. And then we can still do more on the right side. We've got, this would be a negative 12d and a negative 5d. Those can combine. So the left side is still just waiting. So the 24 doesn't change, but negative 12d and negative 5d is negative 17d. And now the extra thing here that we haven't done in this video is, oh, the variable's on both sides. What do we do there? And remember, it's okay to keep the variable on the left. It's okay to keep it on the right, but you have to add or subtract to cancel it on one side. You could either subtract 8d on both sides, but what I'm going to do is I'm going to add 17d on both sides. That's going to be my choice. And I'll mention as I do this, it's going to, doing it this way, I'm going to have a positive 25d on the left. And whereas if you did it the other way, if you had subtracted 8d here, you would have gotten a negative 25d on the right. And that's not wrong, but then you got that negative, and negatives can be tricky. All right, from here, add 76. You got to scroll down a little bit. And we're going to divide by 25. So those would cancel. 25d is greater. By the way, I have not at this point multiplied or divided both sides by a negative, so I haven't flipped. This comes out to 100. And I'm dividing by a positive. Again, if you had subtracted 8d earlier, you would have had negative 25d. You would have needed to flip your inequality. And then don't forget to check. All right, I'm going to skip that for time here, but that's my answer. Check to make sure 4 is the correct number. Does 4 make each side equal? And then choose something. Hey, here we go. 0 does not work for my answer, but check something. Maybe try d equals 5 or d equals 10, something greater than 4. In the original inequality, it should be true. All right, last one for this video. All right, this is a good one here. I could talk for a long time on this one, but basically, to cancel multiplication by a fraction, we'll say to cancel multiplication by a fraction. That's what we're doing. Negative 8/7 is being multiplied by y. What you do is you could divide by the fraction, but the shortcut is you multiply by the reciprocal. Reciprocal, I can spell reciprocal. And that's basically where you flip the fraction. I know we've talked about flipping the inequality. So I'm going to include the negative here, but the fraction will be negative. But I'm just going to put a 7 up top and an 8 on the bottom. And see if I can squeeze that in over here. Negative 7/8. Okay, because what happens over here on the right side, well, first of all, the negatives would cancel. Negative times a negative is a positive. But then you'd have 8 times 7 would be 56. And 7 times 8 would be 56, and you'd still have y, but this is just 1. That's positive 1. That's 56 divided by 56, so it's just positive 1. So it's a nice little shortcut there, okay? So yeah, on the right side, we just get positive y, positive 1y. On the left side, many ways you could do this. I would do negative 7 times 112, and then divide by 8, and I should know what that is. I'm going to pause the video. Okay, so I did that on the calculator. It tells me negative 98 is the result here. All right, and now I multiply both sides by a negative, so I need to flip that inequality. So I started with a greater than, now it's going to be a less than. So this would be my answer. Again, don't forget to check. You can spot a mistake if you check. So, all right. So that video was under 20 minutes. It's not too bad, I suppose. Hope that helps. Keep practicing. You can try the evens on that section. Check your answers in the back. Good luck.